The recommendation is to upgrade to a 2-pole thermostat. This will break both legs of the 220 volts circuit and eliminate the potential for 120 volts exposure. This is the safest and most code-compliant solution. There are code issues to consider as well. NEC section 424.22 A2 requires a disconnecting means for each circuit supplying equipment rated over 120 volts. A single-pole thermostat does not meet this requirement. NEC section 700.11 C3 states that radiant heaters must have a disconnecting means that interrupts all ungrounded conductors. A single-pole thermostat does not interrupt both ungrounded conductors. In the current configuration, one leg of the 220 volt circuit remains energized when the thermostat is off. This creates a potential for 120 volts to be present on the radiant heaters even when they are not in use. A 2-pole thermostat solves this safety issue by breaking both legs of the circuit when the thermostat is off. This ensures that there is no voltage present on the heaters unless the thermostat is actively calling for heat. There are also some additional considerations. If upgrading to a 2-pole thermostat isn't feasible, other safety measures can be taken. Firstly, install a GFCI outlet for the radiant heaters. Secondly, provide clear signage warning of the potential 120 volts hazard. However, it's important to understand that these additional measures do not eliminate the code violation or the safety risk posed by the single-pole thermostat. The reason a 2-pole thermostat is safer and code compliant is due to its ability to completely disconnect the heater from the power source when it's in the off state. This prevents any residual voltage from being present at the heater, which could pose a shock hazard. The National Electrical Code, or NEC, is a set of standards for safe electrical installation. It is adopted by most jurisdictions in the United States and is used as a basis for electrical codes in other countries. The NEC is updated every 3 years to reflect changes in technology and best practices. Understanding the NEC is essential for anyone working with electricity, as it helps to ensure that electrical installations are safe and compliant with regulations. NEC section 424 addresses the requirements for fixed electric space heating equipment. This article covers various types of heating systems, including radiant heaters. It outlines specific rules for installation, wiring, and control of these systems to minimize fire and electrical shock hazards. One of the key requirements is the need for a disconnecting means, such as a 2-pole thermostat, to isolate the heater from the power supply for safety during maintenance or in case of a fault. NEC section 700 pertains to emergency systems. Emergency systems are electrical systems that are designed to provide power to essential equipment and life safety systems during a power outage. These systems are typically found in hospitals, fire stations, and other critical facilities. Section 700.11 C3 specifically addresses the disconnecting means for electric space heating in emergency systems, emphasizing the need to interrupt all ungrounded conductors for safety. The significance of interrupting all ungrounded conductors, also known as hot wires or phase conductors, lies in the fact that these conductors carry the electrical current from the power source to the load, in this case, the radiant heater. When a single-pole thermostat is used, it only breaks one of these conductors, leaving the other one still connected to the power source. This means that even when the thermostat is off, there is still a potential for voltage to be present at the heater. By using a 2-pole thermostat, both ungrounded conductors are disconnected simultaneously, ensuring that there is no voltage present at the heater when it is off. This significantly reduces the risk of electrical shock and other hazards. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect people from electrical shock. They work by monitoring the current flowing through a circuit and detecting any imbalances that may indicate a ground fault. A ground fault occurs when electricity flows through an unintended path, such as through a person's body. When a GFCI detects a ground fault, it quickly interrupts the circuit, cutting off the flow of electricity and preventing serious injury. Installing a GFCI outlet for the radiant heaters can provide an additional layer of safety in case of a ground fault. However, It is important to note that a GFCI does not eliminate the need for a two-pole thermostat, as it does not address the issue of residual voltage being present at the heater when the thermostat is off. Clear signage warning of the potential 120 volts hazard can help to raise awareness and prevent accidental contact with the heater when it is energized. The signage should be placed in a conspicuous location near the heater and should clearly state the potential hazard. However, it is important to note that signage is not a substitute for proper electrical safety practices and should not be relied upon as the sole means of protection. The primary concern with the single-pole thermostat configuration is the potential for electric shock. Even when the thermostat is in the off position, one of the conductors remains energized, meaning that there is still a voltage present at the heater. If someone were to come into contact with the heater while it is energized, they could receive an electric shock. Electric shock can cause a range of injuries, from minor tingling to serious burns and even death. The severity of the shock depends on the amount of current flowing through the body, the path of the current, and the duration of the exposure. In addition to the risk of electric shock, the single-pole thermostat configuration also poses a fire hazard. If the heater were to malfunction, the energized conductor could cause a short circuit, which could lead to a fire. Fires caused by electrical faults can spread quickly and cause significant damage. By upgrading to a two-pole thermostat, both of these hazards can be significantly reduced. The two-pole thermostat ensures that there is no voltage present at the heater when it is off, eliminating the risk of electric shock and reducing the risk of fire. When selecting a two-pole thermostat for the radiant heaters, it is important to choose a thermostat that is rated for the appropriate voltage and amperage. The thermostat should be rated for at least 220 volts and 20 amps to ensure that it can safely handle the load of the heaters. It is also important to choose a thermostat that is compatible with the type of heater being used. Some thermostats are designed for use with specific types of heaters, such as baseboard heaters or fan-forced heaters. Using the wrong type of thermostat could damage the heater or create a safety hazard. The installation of a two-pole thermostat should be performed by a qualified electrician. The electrician will be able to properly disconnect the existing thermostat and install the new thermostat in accordance with all applicable codes and regulations. It is important to never attempt to install a thermostat yourself unless you are a qualified electrician. Working with electricity can be dangerous, and it is important to take all necessary precautions to avoid injury. The cost of upgrading to a two-pole thermostat will vary depending on the type of thermostat chosen and the labor costs of the electrician. However, the cost of upgrading to a two-pole thermostat is typically relatively low compared to the potential cost of an electric shock or fire. It is a worthwhile investment to ensure the safety of the occupants of the building. In summary, the recommendation is to upgrade to a two-pole thermostat to break both legs of the 220-volt circuit and eliminate the potential for 120 volts exposure. This is the safest and most code-compliant solution. If upgrading to a two-pole thermostat is not feasible, other safety measures can be taken, such as installing a GFCI outlet for the radiant heaters and providing clear signage warning of the potential 120 volts hazard. However, it is important to note that these additional measures do not eliminate the code violation or the safety risk posed by the single-pole thermostat. The installation of a two-pole thermostat should be performed by a qualified electrician. The cost of upgrading to a two-pole thermostat is typically relatively low compared to the potential cost of an electric shock or fire. Electrical systems and safety are paramount. The single-pole thermostat on a 220 volts radiant heater circuit presents a significant hazard and code violation. The core problem is that it doesn't fully disconnect the heater. Even when turned off, one leg remains energized, potentially exposing users to 120 volts. This violates NEC section 424.22, which demands a disconnecting means for equipment exceeding 120 volts. The two-pole thermostat is the superior option. It severs both legs of the 220-volt circuit, cutting off all power when off. This eliminates the shock hazard and complies with the NEC. GFCI outlets and warning signs offer limited protection. GFCIs only trip on ground faults, not direct contact with the always-on leg. Signs are easily ignored or missed. Prioritize the 2-pole thermostat upgrade for safety and code compliance.